is the direction cosines of a moving line in two of its adjacent positions are L, M, N and L plus delta M plus delta M and N plus delta N. The small angle delta theta in radians between them is given by delta theta equal to delta L plus delta M plus delta N. Delta theta whole square is equal to L dot L into delta L plus M into delta M plus N into delta N. Or delta theta square is equal to delta L square plus delta M square plus delta N square. Or the last option is delta theta by theta is equal to delta L by L plus delta M by M plus delta N by N. Now we know that L, M, N are direction cosines. Therefore, L square plus M square plus N square equal to 1. First, similarly, L plus delta L plus M plus delta M plus N plus delta N are also direction cosines in the next position. Therefore, sum of their squares is also 1. That is L plus delta L whole square plus M plus delta M whole square plus N plus delta N whole square is also equal to 1. Also, delta theta is the angle between the two positions. That means cos of delta theta is equal to L into L plus delta L plus M into M plus delta M plus N into N plus delta N, which simplifies to cos delta theta simplifies to L square plus M square plus N square plus L into delta L plus M into delta M plus N into delta N. That gives us L into delta L plus M into delta M plus N into delta N is equal to cos of delta theta minus 1. Treat it as third. Now second simplifies to L plus delta L whole square plus M plus delta M whole square plus N plus delta N whole square equal to 1 gives us, when we simplify it, we get L square plus M square plus N square plus delta L whole square plus delta M whole square plus delta N whole square plus 2 times L into delta L plus M into delta M plus N into delta N is equal to 1. The direction cosines of two lines satisfy the relation L plus M plus N equal to 0 and L square plus M square minus N square is equal to 0. Then the acute angle between them is, options are pi by 8, pi by 4, pi by 6 or pi by 3. Since L plus M plus N is equal to 0, N is equal to minus times L plus M. Substituting in the second, we get L square plus M square minus L plus M whole square is equal to 0. That gives us 2 times Lm equal to 0, which shows either L is equal to 0 or M is equal to 0. When L is equal to 0, gives M plus N is equal to 0, that means N is equal to minus M. Hence the direction ratios are 0, 1 and minus 1, because 0, M and minus M it will be. That will be 0, 1 and minus 1. When M is equal to 0, L plus N is equal to 0, N will be equal to minus L, and M is 0. Therefore direction ratios are 1, 0, minus 1. Now we have to find out the angle between the two possible values of L and N. So cos theta is equal to A1A2 plus B1B2 plus C1C2 divided by under root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. So that gives you 1 into 0 plus 0 into 1 plus minus 1 into minus 1, which turns out to be 1, divided by square root of 0 plus 1 plus 1 into square root of 1 plus 0 plus 1, which is equal to 1 by 2. Hence cos theta is equal to 1 by 2, that gives theta is equal to pi by 3. Hence, option D is correct. The two lines whose direction cosines are represented by AL plus BM plus CN equal to 0 and FMN plus GNL plus HLM equal to 0 are perpendicular if the options are AF plus BM plus CH is equal to 0. Second option is F upon A plus G upon B plus H upon C equal to 0. Third option is A upon F plus B upon G plus C upon H is equal to 0. And the last option is none of these. Since AL plus BM plus CN equal to 0, that implies N equal to minus times AL plus BM plus divided by C. The second relation is Fm plus GL times N plus HLM equal to 0. Substituting the value of N, we get minus Fm plus GL times AL plus BM divided by C plus HL plus M equal to 0. Which simplifies to AG L square plus AF plus BG plus minus HL times LM plus BFM square equal to 0. Dividing by M square, we get AG times L by M whole square plus AF plus BG minus HL into L upon M plus BF equal to 0. It's a quadratic in L by M. Let L1 by M1 and L2 by M2 be the roots of this quadratic equation. Therefore, product of roots, that means L1 by M1 into L2 by M2 will be equal to BF upon AG, which can be represented by F upon A upon G upon B. Or in other words, L1 L2 upon F upon A is equal to M1 M2 upon G upon B. If the line